Hi, in this video I'm going to show you how to approximate a roots, right? So given that is a non-linear equation, as you know that many non-linear equations exist to be hardly to use any method to find the roots, right? For example, this equation, this is a non-linear equation, but if this is a quadratic equation, we can using quadratic formula, right? The factorization formula, but there are not all the equations that can using formula or using the method of factorization to finding the roots. Alright, so and look at these cases here. Alright, so if we want to find the roots involving this type of equation, which we name this to be a non-linear equation, alright, and it's also have a combination of exponential function with the linear function here, right? So in order to solving this type of problem in the early mathematics, means that the early mathematician, they were usually plotting the graph. Alright, so for this I have already plot some point for exponential graph, as this is the e to the power of -1, e to the power of 0, right? E to the power of 0, x is 0, e power of 0 is 1, right? So 1. So you substitute with e power 1, you're getting 2.718. So as you keep plotting, I just choosing 4 point and I'm plotting. And now I'm going to sketch the graph. Alright. So they said sketch both graph and use the graph to approximate the to obtain the first approximation to the roots. Means it's not the actual roots. Alright. So now let's look at this. So I'm going to sketch. So it will be sketching. So this will be the exponential graph, right? This will be the exponential graph. So means this is the graph of y equals to e to the power of x, alright? Y to the e to the power of x. So, alright. So now I'm going to zoom in. So let's see. Let's say you have this equation, you have this graph, then later on you need to sketch another graph, right? You need to sketch on another graph. Okay, y equals to 2 minus x, right? 2 minus x. So the y-intercept will be 2 and the x-intercept also will be 2, right? So you know how to sketching the straight line. So you substitute when you intercept the y-axis, okay, as you intercept the y-axis, then you have the x will be 0, so your y-intercept is 2. So when you intercept the x-axis, your y will be 0, so you're getting 2, right? So now I'm going to sketching this line. So sketching this line. So you try to observe that. You try to observe that. So where is the roots, right? So as you can see that if you rearrange this equation, right? If you rearrange this equation, you can rewrite this equation to ex plus with x negative 2 equals to 0, right? So you can rewrite the equation to be ex equals to 2 minus with x, right? Bring it over there, negative 2, adding 2 both sides and minus x both sides, so you have ex to be equals to 2 minus x. So this is where when you're solving the equation, so the roots is meaning that the value of x that can cause the two function here to be have the same y value, right? So let's look at the graph here. So this is the graph for y equals to 2 minus x, right? So this graph is equal, means that the y value will be the same when they are intersecting, right? This is the point of intersection. So means that once they're equal, the x value, the value of x that can causing these two to be equal, right, is called the roots, right? So let's look at the diagram here. So if I sketching, right, I can see that the roots is around 0 to 1, right? But I cannot really estimate what is the roots, right? So you see carefully, I cannot really know that what is the roots, right? I can just say, okay, it's between 0 and 1, or some of you may see it's 0.4, right? 0.4. Some may say 0.3, right? So if you keep zooming, you are still around 0.4, but you cannot actually tell it, is that the exact root? Is this an exact root? This is not an exact root. is not an exact roots. Alright, it's not an actual roots. So these roots we call as approximate roots. That's why the question here is asking you to use your graph to obtain the first approximation to the roots. So I can say that the first approximation are usually using x1. Alright, the x1 means that the approximate roots is not the actual roots. I can say around 0.4. Alright, around 0.4. If you can give any value. Some of you may see 0.3, right? Some of you, while you're sketching, you can see 0.3, right? It depends on how accurate your sketching. Alright, so for now, I know that the approximate root is around 0.4 for this case here. So means that without the knowledge of numerical method in this chapter, alright, now this chapter is about numerical method, right? It's about numerical method. Numerical method. This numerical method is, there are many types of numerical method. In this chapter, we're going to introduce you Newton-Raphson method for solving equation. For now, I just introduce you Newton-Raphson method. Okay, later on I will discuss this in the next subtopic here. So many equations cannot be solved exactly, but various methods of finding approximate variance, right, exist. Alright, find improving this value by an iterative process here. So now the first thing that we do is we know there is a roots between 0 and 1 for this equation, right? For this equation. So I can show you by using apps, right? Apps. So you can open up your you can on your phone. So where you can solve the roots of ex equals to 2 minus x. Alright, you can rearrange this to become ex, right? Sorry, you want to solving this equation ex plus 2 minus 2. You can solving this equation. Okay, but you still need numerical method. So but now, for now, I'm using Desmos. Alright, Desmos, right? So I have this apps. This is a very powerful apps. So I'm going to key the equation. Alright, I'm going to key the equation, this equation into the apps. So which is exponent. Clicking the function here, then you will have this one. You will have exp, right? Exp, exponential, to the power of to the power of x, right? To the power of x. So alphabet x. Then now done, e to the power of x. So later on, plus x minus 2, right? Plus x minus 2. Then this is the graph, which you don't know. Now I draw the graph separately, where the roots I can see is between 0 and 1, right? Between 0 and 1. So now based on the this one, based on this equation, right? The graph. So I can see that I zoom. If I keep zooming, I can see that the graph, the roots is between. Can you see? Can you see that? It's not 0.4, right? Means x is even better. X is even better. So means that by using graphical sketching, I can see it's around 0.4. But with the graph, with the apps that I have, Desmos, I can see, wow, can you see how powerful is this app? You can drag, you can zoom in, and zoom. You can see, right? You can see it's around 0.442 and 0.444. Means that the answer is not 0.4, it's around 0.442 and 0.444. So, but this is still not the best, right? It's not the best. We still cannot see because we keep zooming. Takkan we keep zooming forever, right? So we still cannot see. So we still need a very powerful method in mathematics, which is Newton-Raphson method, to getting that roots, the exact roots. So with human eye, we can't see what is the roots here. With bacteria maybe, or virus, COVID-19, you can see what is the roots here. Alright, so I'm talking so long because I just want to tell you we can using graph to approximate the root, and we can see the interval of roots. The root is between 0 and 1. Alright, I think that's all for this video.